All right, so trig identities. We're looking at this one. We need to prove that this is true, the statement's true. So again, using basically the verifying rules that we've been using, but again, I see these two fractions on the left, which is the more complicated side, and on the right we have just one trig identity. So we're going to need to put these things together. So we've been doing this for the last couple of days, where we have a fraction and we got to get common denominators and put them together. So that's what we're going to do. Okay? So we start by getting common denominators. So on this first one, we're going to multiply the top and the bottom by the other denominator. So it's going to be cosecant x plus cotangent x. And we're going to multiply the top and the bottom. And then this one, we're going to multiply the top and the bottom by the other denominator. Now, if you haven't noticed, these are also conjugates of each other. So that'll help play out things in just a minute. So we get cosecant x plus cotangent x over cosecant x plus cotangent x times cosecant x minus cotangent x plus the other fraction now, cosecant x minus cotangent x over cosecant x plus cotangent x times cosecant x minus cotangent x. Okay, so now we got common denominators. Now we can add them. So my numerator, when I add them, I'm going to get cosecant x plus cotangent x plus cosecant x minus cotangent x all over. And again, since you notice the bottom, they are conjugates of each other. So when you multiply, this is that rule, a plus b times a minus b. When you FOIL that out, you get a squared minus b squared. So on the bottom, when you FOIL that out, you're going to end up with cosecant squared x minus cotangent squared x. So that's that whole, this is a squared minus b squared. Okay? Now at the same time on the top, notice I have positive cotangent minus cotangent, so that's 0. And then I have cosecant plus cosecant, which is 2 cosecant x on top. And if you haven't looked yet, cosecant squared minus cotangent squared, that is one of my Pythagorean identities. And specifically, cosecant squared minus cotangent squared is 1. So we end up with 2 cosecant x as our answer. And that's what we have sitting up there. Okay? So again, this is what we've been doing, getting common denominators and working through it. Okay? So all of this that we did until this step from here to here was algebra, with that exception of using one trig identity. So a majority of what we're doing is just algebra. Okay? All right, number 2. Now, number 2, looking at it, again, going through my steps, we're obviously going to start with the left side. It's the more complicated side. Do I have any foiling or factoring or squared terms? No. We don't have 2 fractions, so we're not going to get common denominators there. We do have 1 plus a trig function on the bottom, so that would say to use the conjugate. Okay, so let's start there. Okay, So basically that means what I'm going to do is I'm going to multiply the top and the bottom by the conjugate of the bottom. So I'm going to multiply the top and the bottom by 1 minus cosecant x. So on the top I get cosine x plus cotangent x times 1 minus cosecant x, like that. And on the bottom, since I'm multiplying their conjugates, again this is the a plus b times a minus b, I get 1 minus cosecant squared x. Okay? Alright, so let's clean up the top a little bit. So we're going to FOIL this out. So I get cosine x minus cosine x cosecant x plus cotangent x minus cotangent x cosecant x on the top. Now the bottom looks like one of my Pythagorean identities. It looks like the Pythagorean identity for cotangent. Okay? Except cotangent is equal to cosecant squared minus 1. Right? So that means that what I can do is I can factor out a negative 1, and that makes my cosecant squared positive and my 1 negative, so that it fits my Pythagorean identity. Right? Which means that this is now cotangent, negative cotangent squared. Okay, so that's one way of doing the bottom. Also, on my formula chart, I have written down that cotangent x is equal to cosine x cosecant x. So this right here I know is cotangent. So that means these middle terms right here, the cotangent, I have a negative cotangent plus cotangent, so this ends up being 0. So on top I'm left with cosine x minus cotangent x cosecant x over negative cotangent squared x. Okay, so here we go. Where do we go from here? Okay, well let's look at where we're trying to end up at. We're trying to end up at cosine. So I don't want to deal or mess up with anything with my cosine in it. Okay? Now, what I can do is I can actually use what I just did here. Okay? And I'm actually going to, instead of dividing by cotangent squared, I'm going to multiply by its reciprocal. So I'm going to get rid of my denominator because I don't want a fraction anymore because it's bothering me. So I'm going to take cosine x minus cotangent x cosecant x and multiply it by negative tangent squared x. Okay. So let's distribute it in. So I'm going to get negative cosine x tangent squared x minus, and plus, because it's going to distribute in. Now cotangent times tangent is 1. So I'm going to be left with just tangent x cosecant x on this side. All right. Where do we go from here? Well, another identity that I have written down says that sine x is equal to cosine times tangent. So this first term right here, the cosine times one of the tangents is going to leave me with sine, so I'm going to do negative sine tangent plus tangent cosecant. And then from there, where do we want to go? So here's the thing. As we're looking at this problem, we are now, how many steps in are we? 1, 2, 3, 4, 5, 6, 7. Okay, and we're going to need to do at least 3 or 4 more steps. But we are way into this, and it doesn't look like we're coming to a stop anytime soon. So there are 2 things at this point we can do. We can either keep going hoping that we can figure out what it is that we need to do, or we start over and try something else. Those are our options. Okay? So unless you can see something right off the bat, maybe we should start again. Now, I do see tangent times cosecant. So let's look at that and see what we can do with that one. So negative sine x tangent x plus tangent is sine over cosine times 1 over sine, like that. So this leaves me with 1 over cosine, which is secant. So I could do that. Sine x tangent x plus secant x. Okay, that helps a little bit. Tangent can also be rewritten as sine x times secant x, like that. Which means we would get negative sine squared x secant x plus secant x. And then I'm going to change sine squared to 1 minus cosine times secant plus secant. Now we can distribute in the negative and secant, so secant times 1, so this is negative secant x. And then this makes it positive, because this distributes in here. And then cosine times secant, cosine squared times secant ends up being cosine x plus secant x. And now we have negative secant plus secant, which leaves me with cosine x. Wow. That is a lot. Okay? But there's a, yeah, so right here, and we go back to it, right here, when we use this, that was our clue of what we should have done in the very, very beginning. At the very, very beginning, I have cotangent sitting right here. If you had looked at your answer and saw, wait a minute, my answer should be in terms of cosine. Is there any way I can change cotangent in terms of cosine? Absolutely. I could have changed the top cosine x plus, and instead of writing cotangent, it would have been cosine x cosecant x over 1 plus cosecant x. And now notice that the top, both terms have a cosine in them. So factor out your common factor. When you factor out a cosine from the top, you get 1 plus cosecant on top, and you get 1 plus cosecant on the bottom, which means this will divide out with this and leave you with cosine x. So sometimes going straight instead of factoring, because I know you guys don't enjoy factoring, but going straight to factoring instead of trying to get the conjugate will cut your time in about half. And today's code is PR3CAL, lowercase.